today we're doing Chapter 1, first set of notes, and it's about classifying numbers. So some definitions: your natural numbers are your counting numbers. So obviously if we were counting, the first number that we could use to count would be 1, 2, 3, and so forth. Your whole number is your introduction of your 0, and then your counting numbers. So my list would go from 0, 1, 2, 3, and so forth. Integers introduces negatives. So now we have our negatives, 0, and our positives. So now our list kind of grows in both directions. So I could say -2, -1, 0, 1, 2, and notice I'm going to put the ... on either side. Your rational numbers would be examples of fractions, and decimals, as long as the decimals have a repeating pattern, or they terminate. And terminate, I mean end. So not every decimal is considered rational, so it has to be repeating or terminating, and any number that can be written as a fraction is rational. Also, all of those above are considered rational. So like, for example, 3 is rational, but it's also an integer, whole, and natural. As far as some examples for your fraction, 1/4, there you go, there's a fraction. This is also an example of your terminating decimal because it ends. 2/3 is a fraction that correlates to the decimal 0.6 repeating. So that would be an example of a fraction that repeats with a pattern. Irrational would be, it can't be written as a fraction, so it's ultimately going to be a decimal that has no pattern, and it goes forever. So it goes forever with no pattern. So some common irrational numbers as far as examples, the most common one we know is pi. And then on the next page we're going to talk about some exceptions. So like the square root of 7 would also be an irrational number. If you type that in the calculator, you would get a decimal. So exceptions, this isn't on your notes, but a quick conversation just to have. So typically I say square roots are irrational. So here I have the square root of 49 versus the square root of 11. This one becomes 7, so this one is rational, whereas the square root of 11 I can't take the square root of. That's why that one stays as irrational. Also in terms of fractions, the square root of, 4/9 versus the square root of 1/5. This one is rational because the square root of 4 and 9 I can take, and I get 2/3. So this is rational. I cannot take the square root of 5, so this one is irrational. So those are kind of two exceptions to the rule. At the bottom of your notes, you're going to have this whole chart. So you're going to take a moment, I would use pencil, put all of these values in the chart, and then once you have it, then you're going to unpause the video and you'll see the answers so you can check your answers. So here would be an example of the correct placement. So go ahead and take a moment. If you have something in the wrong spot and you don't know why it's wrong, go ahead and type it in the question area, and then I can kind of adjust that next time we meet. As far as that, that's all for today, so we're going to stop there.